Thanks everybody for coming in. My name is Chuck Hout. I'm a water resources forester with the Texas Forest Service out of Temple, Texas. And I was a part, or have been a part of the Soil and Erosion Task Force team as part of the Lost Pines recovery effort. We're kind of the environmental arm of the recovery efforts with the county. And so what I'm going to present today are the kind of the guidelines that we've developed for attempting to control and mitigate soil and erosion issues as a result of the Bastrop fire. So I just wanted to start off briefly talking about why this is an issue, why anybody should care. Of course, when a fire comes through, it destroys the vegetation. Okay? Now, vegetation is obviously really critical for holding the soil together. It's critical for helping the water precipitation infiltrate into the soil. It's critical for intercepting raindrops and mitigating the impact that those raindrops can have. You can see in the picture on the top right there that just a single raindrop can have a significant impact on loosening soil and allowing it to move across the landscape. And so what can happen is after these fire events, with no vegetation, we have nothing to hold that soil in place. We get a precipitation event, and we can start to see some of that soil movement. We can get some rilling, and then this gully formation, and then ultimately, what we really want to avoid is the sedimentation on the right-hand side there at the bottom, which is when that soil makes its way into our streams and other water bodies. All of those can have significant impacts, of course. If this is your access road into your property, you're going to have some trouble, and sedimentation can certainly have wide-reaching impacts on aquatic life, on water quality or water quantity by filling in storage areas, reservoirs, and such. So that's the general concern that we're working under. So this concern is kind of complicated, though, by the fact that we're in a pretty severe drought right now. And you can see Bastrop County there is still within the exceptional drought stage, according to the U.S. Drought Monitor. On top of that, it looks like this drought isn't going anywhere. We're kind of stuck with it. So we have the La Nina effect with the cooler Pacific Ocean water, which is doing stuff with the jet stream and making Texas continuing to have dry, warm weather. Okay, so what factors do we expect would increase the risk for any given site to face increased erosion issues? The first one, as I said, if we remove that vegetation, especially starting on the ground, let's say it's a lighter fire, okay, so we just remove the ground cover. All right, well then we have no stabilization for that soil at the ground base. Okay, if the fire is severe enough that it burns the forest canopy, then we lose that rainfall interception protection for the soil. So if we have exposed bare ground, if the canopies burn up, okay, based on our fire severity here, we're going to be looking at increased erosion potentials. Now this one, the fire causing soil to repel water, I don't know if anybody's familiar with that. Hydrophobic soils, what can happen is the fire can be so severe that it creates a water repellent layer, either on top or within a layer below the soil surface. As far as Bastrop goes, I'm not exactly sure if Greg, have you seen any of that at all? And I don't think it's going to be a major concern for us. We see this in the literature and in reports further west, California, in the Rockies, but I don't think that's going to be an issue here for Bastrop. Obviously, slopes that are steep, and we do have some steep slopes, and I'll show you. We definitely have steep slopes within this fire area, and those are going to be problematic, and definitely an increased risk for soil erosion. And then obviously the rainfall in large amounts over a short period of time, but that's the big question. We don't know if or when that's going to happen. We can expect rain We can expect some sort of rainfall event to occur, but we don't know, obviously, what that rain event's going to be like. So there's some definite uncertainty as we move forward here, but what I'll do is try and present, kind of the basis for what we're going forward on as far as assessing risk. So this is the Bastrop fire perimeter. I'm sure most everybody's familiar with it. This is the Old Potato Road fire up here. Obviously Tahitian Village, Bastrop, 2171 going through there. Okay, what this is a watershed map for the Bastrop region. Okay, and so it's hard to see, but we still have this Bastrop. The park is right here. But what I wanted to show you with this is these watersheds, these areas where all the water collects to one local area. This primary one that the fire burned through here, this is the Allen Creek watershed, okay? And so these are the areas that we could expect water quality impacts to occur. If we have erosion events, that sediment is going to make its way into this system right here, and it's going to eventually make its way into the Colorado, which is what we see across the bottom here. So I just wanted to point out that these are the different watersheds that the fire burned through, and the primary one is the Allen Creek watershed right here. So as I said, we do have slopes within the Bastrop fire. This is a slope percentage map. So the green areas are the lowest slope, 0 to 5%, going up to the red areas, which are greater than 20%, areas with slopes of greater than 20%. Okay, so primarily down here in Tahitian Village, in the southeast side, we have some steeper slopes in this region. Over here, the park, I don't know if anybody was over next door listening, but they were kind of amazed when the brush and the understory cleared out, how far they could see and the slopes that they actually had. So these areas are going to be very significant concerns for erosion, and something that we're going to need to keep an eye on moving forward.
I have a question.
Sure.
So the green areas we don't need to worry about then, right?
I wouldn't say that, and I should qualify that.
Oh, okay.
There's
I live in the green area at the top.
Okay. Here's the thing. Along with the slope steepness, another concern is slope length. Okay. So you can have a real steep slope that's only maybe 100 feet long. If you have a quarter-mile slope that's like a 3% grade, but a highly erosive soil, that water can pick up velocity. And then the two things that we'll talk about here is controlling water volume and velocity. If that water picks up velocity across that grade, what happens is it has the ability to pick up more sediment. And as it carries more sediment, it can release more sediment and carry more sediment. Okay, so it's kind of a repetitive erosion process. And so these are certainly areas, the steep areas are certainly areas where we need to be concerned, but that doesn't discount the lower slopes as well.
Great.
If anybody does have any questions, feel free to let's keep this casual. Just go ahead and shout them out, and I prefer to answer them as we go along here. Okay, so this is a map that's really complicated, but I'll try and walk you through it here. You can still kind of see the fire perimeter right here. Is that clear? Can everybody see that? Okay. So what this is showing is the areas. It's showing soil areas. Okay, and each of these polygons of the same color are areas of soil with similar properties. Okay, and so the colors represent the water erosion potential of those soils. Now, water erosion potential is based on different factors of the soil, like the soil particle size, how much organic matter it has, where it is on the landscape in regards to slopes and topography. Okay? And so our soil erosion potential ranges from very low to very high. And you can see that the majority of the soils, the northern half, are pretty much very low to very low. And really, we only have some major concerns, or some concerns, I should say, with the moderate soils here in the southern half. You can see that in the very, very steep areas, we do have some soils with a very high, water erosion potential rating. And what this means is the very high soils, and high means that you could almost expect soil erosion to occur as a result of water action. The moderate soils, which is what we have the most of, as far as any sort of erosion concern means there's an elevated concern, but it's questionable as to whether we're going to see any erosion effects from precipitation event. So you can see here, I don't know if you can make out these numbers, we have 29.1% of the burn areas within the moderate erosion potential, and only 0.2% are at the high level. So there's a lot of question there. Yes?
Can we look at this online?
This map is online. It's on the county website.
On the county website?
Yeah, the Bastrop County
With
website under the
legend
disaster.
on it?
What's that?
With the legend with it?
Yes, the legend and the numbers. Yep, this exact map is available on the website.
Under what heading?
Uh,
Under what heading? I mean, where do we find it?
If you go to the disaster relief, and Greg, is there an environmental section to that? There's a whole list of environmental resources on the disaster webpage.
Yeah, it's under,
I can't remember exactly what this map is called.
I think it's called wildfire recovery.
Yeah.
And there's a whole list of articles.
it's well marked on the home
See
page.
some maps?
You know, you go through the post-burn recovery part, you have to dig out there, but as far as where the section is, it's well marked.
Yeah. You shouldn't have too much trouble once you get on the disaster webpage finding this. Any other questions before we move on to the next one? Okay. So what this shows then, on top of that, this is another resource that rates the soils within the burn area. What this one's looking at is potential for damage by fire. And what that means is this rates the soil potential to be damaged biologically by a severe fire. Okay? So areas of high risk within this rating system means that it's almost expected, or you could expect some level of damage to the organic component, the organic matter within the soils, the biological components, any microbes or other bacteria living within the soil component. And so you can see within this soil rating system, we do have a fair amount within the high and moderate. Again, moderate is, we're not really sure, but there's an elevated chance. So 53 or 52% of the burn areas within that high soil damage rating, and 41.6, an additional 41.6 is within the moderate. Okay, so we do have elevated risks for soil damage, and what that could mean is that, one, we don't have that organic component that helps hold the soil together. It reduces the erosiveness of the soil, and then also we could be, it could take longer for the vegetation to recover in those areas because the soil has been so severely damaged.
I have a question. What's the duff layer?
The duff layer, okay, so if we're talking about the organic component of the soil, the top part of the soil, typically what we have is a litter layer, which is the needles and twigs and stuff that isn't quite decomposed yet, and then underneath that is a duff layer, and that's the same material just decomposed, okay, at a further state of decomposition.
Excuse me, what
Yes.
are the other areas outside the burn ban areas that are red also? Could you
This
show
is
me
this is rating all the soils within the county, actually.
that?
Okay,
Not-
so this is just a rating. This is not something that we've measured. Okay, this is something that was rated before. This was actually rated by the Natural Resource Conservation Service, the NRCS, and they have all the soils rated for not only Bastrop County but for the entire state of Texas. Okay, and so this is just the information that we were using to try and establish the risk. What kind of potential risk are we looking at as far as soil erosion? Okay, so this is the fire severity map, and maybe you've seen this, maybe you haven't, but this is showing exactly, this is what the impact of the fire had on within the fire burn perimeter, okay? So you can see everything within, everything that's red colored is the heavily burned areas. The orange, which might be a little bit tougher to distinguish, is the moderately burned. Yellow is light, and the green is scorched. The dark green is unburned. Okay, so these areas of moderate, these areas that were moderately to heavily burned are going to be, again, have an increased risk of soil erosion. Okay, so with all these factors combined, we have moderate to high water erosion potentials. We have high fire damage within the fire perimeter. And so we were just trying to figure out what the risk might be. This map attempts to do that, okay? This is not an easy thing to figure out what the risks are and where they're going to be. But what this does is it overlays those layers that we've been talking about, okay? So the red layer is the fire severity from moderate to severe. The blue layer is all the soils that were rated moderate or medium to high water erosion potential. Okay, and then the black areas are very steep slopes. So you can see that it's tough to say where we're going to have issues, okay, because there's so much of an area. We have, high fire severity mixed with moderate erosion, an elevated erosion potential throughout most of the southern half of the burn area, and then we obviously have all these steep slopes within this region over here, and all the other places within that slope map that I showed earlier. So it's tough to say. I don't have a real clear crystal ball that could say these are the areas that we need to focus on, these are the areas that we don't. There's a lot of concern for erosion potential. There's a lot of question as far as precipitation events as to what can occur. So I just want to go over really quickly some of the guidelines that we developed for the short term. Okay, these are the things that we can do to try and help from causing any further soil erosion issues to occur. So the first one is plan for soil